Good morning, children. This is Dr. Sekhar Chandra. Welcome to CEI. Today I'll teach another chapter, that is water. So let me start the chapter, very important in class 9, water. Now, there are two types of water we will discuss today. These two types are, one is hard water, another is soft water. Hard water and soft. I repeat, two types of water, hard water and soft water. Now, what is hard water? Now, water which are treatment with soap solution, or water if it is agitated with the soap solution, if lather or foam is not formed, then it is called hard water. I repeat, when the water is treated with or agitated with soap solution and then no lather or foam is obtained, it is hard water. And soft water, water which on treatment or agitated with soap solution produces lather or foam, it is called soft water. Okay, so two types of water, hard water and soft water. Now, what is the causes of hardness? Now, the main reason because the hardness is caused due to the presence of soluble bicarbonates, chloride, sulfates of calcium and magnesium ion. I repeat, the hardness is caused due to the presence of soluble bicarbonates, sulfates, chlorides of calcium and magnesium ion. So let me say, hardness is caused due to presence of bicarbonate, sulfate and chloride ion of calcium and magnesium ion. Calcium and magnesium ion. That means the hardness due to the presence of soluble calcium bicarbonate or magnesium bicarbonate or soluble of calcium sulfate, magnesium sulfate and soluble of calcium chloride and magnesium chloride. The next part is, there are two types of hardness. One is temporary hardness and another is permanent hardness. Temporary hardness, and there is permanent hardness. Now, what is the difference between them? Temporary hardness is caused due to the presence of soluble bicarbonates of calcium and magnesium ion. And permanent hardness is caused due to the presence of soluble chloride and sulfates of calcium and magnesium ion. That means temporary hardness due to the presence of soluble calcium bicarbonate and magnesium bicarbonate. Permanent hardness due to the presence of soluble calcium chloride, magnesium chloride or calcium sulfate or magnesium sulfate. So let me write, temporary hardness is caused due to the presence of soluble calcium bicarbonate and magnesium bicarbonate. Soluble calcium bicarbonate, magnesium bicarbonate. And permanent hardness is caused due to the presence of soluble calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate. So let me conclude. Hardness, there are two types of hardness. One is temporary hardness, another is permanent hardness. Temporary hardness is caused due to presence of soluble calcium bicarbonate and magnesium bicarbonate. On the other hand, permanent hardness is caused due to presence of soluble chlorides of calcium, chloride and sulfates of calcium and magnesium ion. That means soluble calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate. Is that clear? Now next part will be removal of hardness. How will you remove hardness? First I will discuss that is removal of temporary hardness and then permanent hardness. So temporary hardness, let me start. There are two methods are there to apply to remove temporary hardness. One is by boiling, another is Clark's process. Now first, removal of temporary hardness. Removal of temporary hardness. First method is by boiling. Now by boiling, what will happen by boiling? When temporary hard water is boiled, then bicarbonates of calcium and magnesium are converted as calcium carbonate and magnesium carbonate and deposited. So we can remove by boiling temporary hardness. I repeat that by boiling temporary hardness can be removed because soluble bicarbonates form insoluble carbonates of calcium and magnesium. What will be the reaction behind it? Calcium bicarbonate, when it is heated or boiled, it will form calcium carbonate plus carbon dioxide plus water. So soluble, it becomes insoluble. Similarly, magnesium bicarbonate, when it is heated, it forms magnesium carbonate as precipitate, carbon dioxide and water. So let me repeat. When calcium bicarbonate is heated, it is decomposed to calcium carbonate. When soluble calcium bicarbonate is removed as insoluble calcium carbonate and deposited. So this is removed because this is converted into insoluble calcium carbonate and separated from temporary hard water. Similar phenomena or similar reasons can be found in case of magnesium bicarbonate, where magnesium bicarbonate is decomposed to magnesium carbonate and separated from the hardness from the temporary hard water as a magnesium carbonate. Soluble magnesium bicarbonate is converted into insoluble magnesium carbonate and separated from temporary hard water, and it becomes soft water. The first method. Second, Clark's method. Second is Clark's method. What is that? Now, this method, when slacked lime is mixed with the temporary hard water, then what will happen? That soluble bicarbonates is again converted into insoluble calcium carbonate. Soluble bicarbonate is converted into insoluble carbonates because when slacked lime is used to the temporary hard water, slacked lime, which is nothing but calcium hydroxide, this calcium hydroxide reacts with calcium bicarbonate to form calcium carbonate as a precipitate. Similarly, calcium hydroxide, that is slacked lime, reacts with magnesium bicarbonate to form magnesium carbonate, calcium carbonate and water. And they are removed as carbonate, as a precipitate, and removed from the temporary hard water. And in this way, temporary hard water is becomes or converted into soft water by removing soluble bicarbonates. So let me write the equation. Now here is calcium bicarbonate temporary hardness caused, and then slaked lime CaOH twice. We get calcium carbonate plus water. Similarly, magnesium bicarbonate plus slaked lime, we get calcium carbonate, magnesium carbonate and water. So this soluble becomes insoluble. Now let me repeat. Slaked lime, which is nothing but calcium hydroxide, it will react with calcium bicarbonate to form insoluble calcium carbonate and separated. Similarly, when magnesium bicarbonate reacts with calcium hydroxide slaked lime, it forms calcium carbonate, magnesium carbonate and water. Okay. So in this way, we can remove temporary hardness. So let me conclude. Temporary hardness can be removed by two methods. One is by boiling, when soluble bicarbonates are converted into insoluble carbonate, and second by treatment with slaked lime. Slaked lime is nothing but calcium hydroxide, and this slaked lime reacts with calcium bicarbonate and magnesium bicarbonate to form insoluble calcium carbonate and magnesium carbonate and separated from the from temporary hard water, and it becomes soft water. Okay. Now next is removal of permanent hard water. We know that permanent hard water contains soluble calcium, soluble chloride and sulfates of calcium and magnesium, and that means soluble calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate. How do you remove those soluble chlorides and sulfates of calcium and magnesium ions? We can remove by heating with sodium carbonate or washing soda. The method which is applied to remove permanent hardness is using sodium carbonate or washing soda, that is Na2CO3.10H2O washing soda. So what is that? What will be the reaction behind it? When it is treated with hard water, sodium carbonate reacts with respective chlorides and sulfates to form insoluble carbonates of calcium and magnesium. That means when sodium carbonate reacts with calcium chloride, it forms calcium carbonate and sodium chloride. When sodium carbonate reacts with calcium sulfate, it forms calcium carbonate and sodium sulfate. Similarly, magnesium applicable in the same way. So let me write the reaction for the removal of permanent hardness. Removal of permanent hardness. Method is only one, by using washing soda. Washing soda formula you know, Na2CO3 dot 10H2O. This is washing soda. So magnesium chloride plus washing soda Na2CO3, we get magnesium carbonate plus sodium chloride. Similarly, calcium sulfate plus sodium carbonate, we get calcium carbonate plus sodium sulfate. Similarly, magnesium sulfate plus sodium carbonate, we get magnesium carbonate plus sodium sulfate. And finally, one more reaction is there, calcium chloride plus sodium carbonate. We get calcium carbonate plus 2 NaCl. So, this soluble magnesium chloride is deposited as insoluble magnesium carbonate. So, magnesium chloride is removed from the permanent hard water. Similarly, calcium sulfate soluble is separated as insoluble calcium carbonate. So, a permanent hardness can be removed by applying sodium carbonate. Similar reactions in case of magnesium sulfate and calcium chloride also there. So, let me conclude that permanent hardness can be removed by applying washing soda, because washing soda is nothing but sodium carbonate, and this sodium carbonate combines with the soluble chlorides and sulfates of calcium and magnesium ion and then separated as or deposited as precipitate of calcium sulfate, calcium carbonate and magnesium carbonate and remove permanent hardness. Okay, so I discussed about the removal of hardness, temporary and permanent hardness separately. But now I will teach both of you together. That is hardness, that is softening of water. Okay, the next class I will teach softening of water, means removal of hardness together, both temporary and permanent. So let me conclude today. However, the next class I will teach another portion of this remaining part. So, if you like this video, please do like, share and subscribe. Thank you.